Okay, so this is our Titanic machine learning from disaster project.
I'm Jennifer Oviedo.
Hi, I'm Nathaniel Gosden. All right, so here is our table of contents slide. We have our first slide, which is historical background, then teamwork and timeline, then Titanic data set, then technical approach, then our models overview, and then our next steps. All right, so this is the fun part. The historical background of the Titanic, it's a really interesting. It was the most advanced ship of its time. It was nearly the fastest from what White Star Line built. It was built to be a palace on the sea with luxury that you basically couldn't imagine in a onshore hotel, something like with new luxuries like exercise equipment, electric baths, so on and so forth. It was thought to be unsinkable because of that. The designers, they literally believed with all their water, they had these bulkheads. Titanic had seven bulkheads that could be lowered, and the event of emergency, the engineers believed there was no way, even if the worst happened to the Titanic, that it could ever sink. And because of that, the deck plan called for less lifeboats, which the engineers believed would clutter the Titanic and take away from its luxurious aesthetic. This was at a time where there was a record being broken every single day. And this was just thought to be just the culmination of all of that. And in its maiden voyage, it sank disastrously. Over half of the people that sailed with the Titanic died. And it caused a huge spectacle, and there were many, many inquiries into the sinking of the Titanic. So not only is it was it known as a very ironic twist of fate, but it's also very, very, very well documented. And it changed how people travel across the ocean as far as safety goes.
Okay, so in terms of our teamwork and our timeline, knowing now the history of the Titanic, then we decided to participate on a Kaggle competition for which the main goal is to try to predict passenger survival based on the data set from all of the passengers that were aboard the Titanic back then. So for this, we decided to communicate mainly through Teams and meet a couple times after class. And in order to work on our models, we chose Python as our main programming language. In terms of our timeline, we decided to divide our work in two phases. The first phase went from March 30th to April 10th, in which we worked on a Titanic Kaggle tutorial that was included in the competition. And then we decided to explore different models in order to select four of them and work a little bit further on the exploratory data analysis. And after doing this, we continued through the second phase that went through April 10 to April 27th. And out of the four models that we selected on phase one, we decided to select the top two models to optimize them even more, and try to aim for a 0.8 score on the Kaggle competition, which sadly we could not achieve because this is actually a little bit harder than it looks. In the Kaggle competition, there were two Titanic data sets, one for training our data and one for testing our data. The one for training included 891 records, and the test data included 418 records without the feature of survival, since we wanted to use this data set in order to predict our passenger survival. In terms of variables that were included on both of the training sets, except for the survival, we also had the passenger class, either if they were from first, second, or third class, sex, whether they were females or males, their age, the number of relatives, which included numbers of siblings, children, parents, and spouses, their ticket numbers, passenger fare, cabin number, and the port of embarkation. And considering all of these variables, we decided to explore our data a little bit further. So we looked at the survival of our passengers based on their gender. And we can notice that even though there were more males aboard the Titanic, they actually did not survive as much as the females. But this is due because whenever there's a crisis, we do prioritize female and children first. In terms of passenger class, we can also notice that not many people survived, and out of those that did not survive, the third class was the most impacted out of it, while for those that did survive, the first class had a better advantage in the groups. And finally, we did decide to divide all of our passenger per groups, depending on their age, from children, teens, young adults, adults, and seniors. And we can notice that on the children, most of them did survive, and the more numerous groups out of the passengers corresponded either to the young adults or the adults that range in the ages from between 18 to like early 60s. For our technical approach, then, as we mentioned before, we did select 4 models. These 4 models came from this for loop that we created. We created a list of different models and classifiers, and our for loop iterated through each model by training it with our training data, also by making predictions on the test data, and then exporting all of the results on separate CSV files. So like that, we could automatically upload all of these files on the Kaggle competition and get a better idea of how our models were processing the data and trying to predict the survival rate of our passengers in the Titanic. And the outcome that came out of this for loop was this list that you see in the bottom with these 6 different models. And out of those 6 models that had the highest accuracy, we decided to pick those top 4 models, and Nathaniel worked on the logistic regression and support vector classifier, while I worked on the random forest and the gradient boosting classifier.
Okay. So as you know, I did the logistic regression and the support vector classifier. Logistic regression, although it did score the highest out of the 2 on the Kaggle, it was actually the simplest. And it is also was the one I started with. The logistic regression, it started with just a couple of basic features being taken at face value, not really modified, just kind of extracted and then run through the model. With the new and improved logistic regression, many of these features were parsed. There was feature extraction, like with titles as a good example. And then more information was looked at, like the embarkation, class, sex, those things were already included, but there were more ways that these features were compared, and it greatly increased the accuracy. But once it goes above 0.78, it kind of hits a wall. I was hoping to support vector classification because it's a more complex model, could solve that, but it didn't even improve when I put in the Kaggle, although the Python did say it had an accuracy, a medium accuracy that was better than 80%, but the Kaggle ultimately did not think that.
Yeah, the case was exactly the same, something similar with my models. You can notice that for the initial models that we obtained from the for loop that we mentioned earlier, did increase a little bit once, for example, in my case, I converted categorical variables into numerical format after imputing the features for age and fair with their mean values and embark with the most frequent value, and even creating a family size feature by combining the numbers of siblings, parents, children, and the passenger itself. And even with these changes, we did get some improvements on the Kaggle score competition, which are circled in red. And for the gradient boosting, we did get an improvement up to 0.78, and for the random forest, a similar value. But yes, just like Nathaniel mentioned, we did try to optimize them even farther, but it is very difficult to do so, even though we're very close to that zero point 0.8 score that we were trying to aim to at the beginning of this project. Um, but yeah, our accuracy is also improved a little bit more on the Python code, but this did not reflect as much on the scores in the competition.
Oh, my so this is the for my model that did better than the standard vector classification. This is by confusion matrix and just the what the improved model ultimately got. As you can see, it says the accuracy is above 80, but it's different with the Kaggle. I don't know how the Kaggle finds out its own value, but we did get around an 82% to around 80% accuracy rate with the logistic regression in Python. And this is, of course, an approved model. And also, I took a book out of that one person that presented his graph with the feature importance. That's a very good idea. As you can see in our feature graph, the things that the features that had the biggest effect was sex, title, and P class, and so on and so forth, like if they had kids or not and their age.
Right, and the case was the same for my random forest regression model, which also was the highest, got the highest score in the Kaggle competition for my part of the project. I also included a confusion matrix, which both in Nathaniel and my case show that our models just simply do better at predicting the cases of those passengers that did not survive. And this is mainly given by the fact that most of the passengers in the Titanic did not survive. So our model has a greater chance of training on that data and testing it and predicting that outcome much better than those passengers that did survive. On my accuracy, I did also get a 0.82 for my model. And just like Nathaniel's, I did a plot that shows the importance of certain features in our models. And we can see that sex, fare, and the passenger class were probably the ones that influenced the most on the survival or non-survival of our passengers. So in terms of our conclusion, our next steps, we do think that we already have very strong scores in the competition. We did plan on improving our scores to 0.8 if it was possible, but sadly we're hitting the deadline for our project. So we are very happy with our results. And based on that, we're going to be writing a technical report that is going to portray our models, the results, and also all of the plots that we did show in this presentation. And this technical report, along with all of the code that we worked on Python, is available to you on our GitHub repository, and you can find the link right there. So thank you so much. And if you have any questions, just let us know. Thank you, Nathaniel.
Yeah.